Okay, good morning, everyone. Welcome to Consensus Layer call number 97. Danny's out this week, so I'll be the one facilitating this. We have quite a few things on the agenda. I think this is our first CL call since the post-merge one. Lots of stuff around withdrawals, then getting to this conversation around the engine API and the block value that we sort of didn't have time for in Alcore Devs. And finally, there were a couple other topics. So the rebase of the 4844 spec on Capella, the proposal for historical batches, some follow-up of the Goerli discussions and a way we can potentially fix that on the CL side. And then some updates from MEV-Boost. And I think that should cover it. Yes, I'm just covering for Danny being quote unquote out for a long time. I believe Light Client saw Danny in person, so hopefully he's still around. Okay, I guess to kick us off, so there's two PRs on the withdrawal side that we've been discussing. There was the one about moving withdrawals through a single queue by Danny. Tons of discussions on that, and then POTUS added or opened a new draft PR this week, which removes the queue altogether, and it seemed like there was some support on that, but then also a couple of pretty significant comments in the past day or so. And POTUS could not make it on the call. Is there anyone who wants to just kind of share quickly the context and where things are at on that PR?
Test. Yep. Can you hear me?
Yes, we can. Yeah.
Yeah. Sorry. Yeah. So I guess POTUS can make it. I thought he could make it, but yeah, I guess I could give a high-level summary on like POTUS approach. So TLDR currently to process withdrawal, there's during epoch processing, there's two loops, one for full withdrawal and one for partial withdrawal. And this is not ideal for both like complexity and performance perspective. But one thing that's good about this is that full withdrawal is treated differently than partial withdrawal. So therefore it has some variety and some people really like this. And this is also easier to test for the spec test perspective because now you have full and partial and because they're separate, right? And then he opened a PR that's 3042. And this was born to put withdrawal into a single function, single pipeline. Therefore, it is slightly simple to implement. And then, but this has a downside that now partial and full withdrawal, they are treated equal. So this shift the fairness under certain circumstances, and therefore full withdrawal may take longer. And this is also like harder to write spec tests because everything's under one loop, and client may have to implement some caches around it, but those are client implementations. So POTUS, after seeing this, POTUS actually came up with something else because he thought that, well, maybe we don't need the queue, right? So we don't need a queue, therefore this is actually much simpler from the spec and client implementation. And then you can remove constants such as like max withdrawals per epoch, and then also max withdrawal queue limit. You also reduce pressure on like epoch processing. So, and then also the lookup for finding withdrawals in a block for like happy case are small and fast, since the per block limit is quite small. This also has the same argument versus the one queue approach, such that the full and partial are treated equally, but that can be further extended or improved. For example, like you can use some ratio system that you can give priority over like full withdrawal. There are some concerns such as that, well, like if the network has like inactivity over 5 days, validators get slashed before processing partial withdrawal. And then with those concerns, it could get more expensive. But generally, I guess from the comments I'm seeing from other from all the client teams, it doesn't seem too bad. So yeah, it seems to me like most of the teams have like approved on this PR, and this seems like the way to go. So yeah, I'm curious if I miss anything. People feel free to chime in, and please let us know like how we can proceed further.
And I think there was. Oh, sorry, Marius. Yeah, go ahead.
So I really have no idea about this. But one thing that I had a question about when reading is, with the withdrawal queue, the order of everything is under consensus, right? With this new approach, is the order of the like, will every node deterministically come to the same order, or can you, like, I don't know, prioritize your own withdrawals over others, or just say I didn't have any withdrawals and kind of like censor withdrawals or whatever?
It's fully deterministic. You can't censor.
Okay, perfect. That's good.
And yeah, like reading, I guess skimming the PR and the Discord in the past day, it seems like pretty much all client teams support this. But is there someone who opposes POTUS's proposal and thinks Danny's, like the 3042 would be a better way to go? Thanks, Marius.
Can someone give a like, I don't know, one paragraph description of how withdrawal order is determined when there are more withdrawals than can fit in a block? For those of us that aren't intimately familiar with this.
In the new approach or the current depth?
In the new approach.
So you have a pointer that's persisted in the state, and this would keep looping, and the pointer will process withdrawals up to the capacity of the block. Then it would stop, and that would be persisted on the state, and that continues on the next block.
So is there still a withdraw queue? It's just in a different place then? What you're describing sounds like a withdraw queue.
So I would think in terms of a pointer that loops over the state and just stops when there is no more block space for withdrawals.
Right, and so the thing is, you don't need to store the full queue, you just need to store that pointer, is that correct? And this is why it's simpler?
Yeah, so the way it was working before is if at specific epoch, if there is a large amount of withdrawals, that would be queued by order of index from less to highest, and that would be the queued as the epoch progresses through the blocks. Here it's just, if we start at index 0, if we can process, say, 120 indexes worth of withdrawals, then it will stop, and then at the next block it will continue. So after the point that it has passed, if index 1 becomes available, it will need to wait for this pointer to loop over the set to be included.
So let's say 100 people, let's say we have room for 10 withdrawals in a block, and 100 people all at the same time decide, just miraculously, they all simultaneously say, I want to withdraw right now. So you have 100 people that want to withdraw, but only 10 can fit in the block. So presumably those 100 people need to line up in some way or somehow be sorted, right? Are we still reporting those 100 people, like, or only 10 of them get in, just the first come first serve, another 90 try again on the next block and race each other?
So it's a first come first serve by index, provided that you are after the pointer.
So all 100 people would register themselves as wanting to withdraw, and that would still happen. Is that correct?
Well, it depends on your validator index.
Can I probably interfere a little bit? So And so Mika, there might be a misconception. You do not request to withdraw, you request to exit a validator, I guess. That's what you're, so all exited validator automatically will be available for withdrawal. So what we're gonna do is, you start today, your pointer was pointing to validator number 100, and you're gonna check. 100 is available to withdraw, okay, good, then we put it in a block. We go to 101. Is this guy available to withdraw? No. Okay, so we go to 102 until we finish like getting the 16 ones that we can put in a block, and then we continue after in the next block with the next indices. So it doesn't matter when you actually are out for withdrawal. It just only matters what's your validator index.
And I'm guessing that the clients don't need to actually loop through all 400,000 validators. There's some easy way to skip over most.
You will, so there's a very nasty case, which is that no one wants to withdraw. So no one wants to take out all of their ETH. And also the whole network has been leaking for the last 5 days. So in this situation, then you're gonna go over the whole validator set and you're not gonna find a single withdrawal.
I think if you're also looking and there are just a few people that are willing to withdraw, it's also like a kind of nasty case. Because you might not meet them like scanning for, say, 100,000 validators.
And those nasty edge cases aren't so bad that the clients will fall over. Like you can still handle that within 12 seconds, no problem.
Yeah, we can handle those. So we are doing anyways a full validator set loop in 4 choice on every block. And last time I timed it, it was 5 milliseconds.
Okay. There's been talk in the past about wanting to allow people to exit without withdrawing. Would this make that significantly harder? Should we decide to implement it in the future?
So what do you mean?
All of our withdrawal methods will automatically withdraw you if you have an ETH1 withdrawal address. So,
yeah, I think that the idea with exit without withdraw is that if you know you're going to have an outage for some amount of time, like let's say I'm going on vacation, I'm going to turn my computer off for 3 weeks. I want to exit, but I don't want to go through the whole withdrawal process because as soon as I get back, I'm going to rejoin right away. The idea is to make it so users, again, this is just a proposal. This isn't final or anything, but the idea is that someone might want to exit, leaving their stake on the beacon chain, and then when they return, they would re-enter without having to go back to the execution layer and then back to the beacon chain. Would this change make it so such a feature is harder to implement? Should we decide to implement such a feature?
Not going to be harder or easier. There are research projects about putting validators to sleep, and yeah, so nothing is set. This proposal is not going to make it any harder or any easier. Most probably we're going to have, if we want to implement that, we're going to have a different figure instead of exited, but sort of like sleeping validator.
Okay.
Yeah, I think it should be easy to skip the validator to pushing in the withdrawal queue if you have that flag of sleeping set for a particular validator.
So does anyone have an objection to Protus's proposal?
So this is not an objection, and if someone has one, they should chime in. But there was like one kind of open question on the PR, which was if we want to bound how much you look per block or per slot. I don't know, Potos, do you have any thoughts about that?
Yeah, so we perhaps I'm not counting correctly, but I think that most of us would not object that, and some people really wanted this, so I think it's probably a good idea to add a bound. My only objection to the bound is that I think it should be very large, because it should give us enough time so that holes in the validator registry given by validators that actually exited do not become so so many that we're going to be proposing blocks without all withdrawals available. So I think this constant, if we put it, which I'm not opposed to it, should be of the order of 2 to the 17. So say like 100,000 validators or something like this. But I think everyone agrees that there should be a bound. To have a constant bound is better than having this ever-increasing number of validators that we're going to continue depositing.
Yeah, I think that makes a lot of sense. So perhaps in like the next day or two, we can work on that. And yeah, it sounds like there's pretty complete agreement on 3068.
So I want to add, I did a proposal on the PR that had bugs, but it should be fine with a bit more complex code to have both a no queue approach plus no wait for full withdrawals. So extend approach of POTUS to just have a double pointer and loop for full and partial independently. I'm not sure if there's support for that, but that would be like the best of both worlds.
Does anyone feel strongly enough about prioritizing full withdrawals that we would add more state to the beacon state?
So it would add 4 bytes, and it's not exactly prioritizing. It's just allowing them to be processed faster.
So the problem with that approach is that it makes the full loop on every block. If there are no, so we do expect times where people are not fully withdrawing and are only partially withdrawing. And I mean, this should be the common scenario. And this proposal will make it so that we run the full loop on every single block. It's not something that's particularly bad. It's just that it's just more complex and it has this full loop on every single block.
I mean, you don't really have to do that. So if you at every epoch do one loop and pre-compute the list of potential withdrawals, that should be sufficient. I did a demo implementation 2 days ago, and it's not complicated. And for the normal cases, it should be extremely light, and you can have this cache attached to the state. You can have either being forking or not. Each one has different trade-offs, but that easily prevents having to loop on every block.
I mean, my opinion is that it's probably worth prioritizing full withdrawals if it's like not too much additional complexity, just because otherwise in the normal case, I think if there aren't many full withdrawals, you'd be waiting like around 2 days or so, because almost everyone on the network will have partial withdrawals pretty constantly.
So I think it's important to clarify that there is no prioritization here unless there is a match/event, because the churn is really strict. So unless there is a bump at the start for people that have exited before we activate Capella, partial withdrawals will take the vast majority of withdrawal block space. So it's just a matter that the approach of having the partial pointer affecting the full pointer, it will just add an extra delay. But I don't really buy the prioritization argument.
So then why would we make this change? I thought it was to prioritize full withdrawals.
So it's not really to prioritize, it's to not add a delay, an artificial delay on them.
Okay, well, I'll just echo what Micah was saying in the chat. Just like, even if it's just like only 4 bytes, it's like a whole new field and it's more to test. And so like generally, I think we need like very good reasoning to include stuff in the beacon state, right? Because like we'll have to maintain it forever and test it forever. So what I would suggest is we get 3068 in a good place, and then you could open another PR to that once that's together. But yeah. Personally, I think we should just keep it as simple as possible.
Can we add the second pointer that you're referring to? Can we add it later just as easily as we can add it today, or is there some significant advantage to adding it up front?
No, that could be added later. And I agree. I would vouch for simplicity. It's just that we can avoid this UX penalty. So I think we should try to. But yeah, I agree. If it's complex, I would be totally fine not doing that.
My recommendation then, if this can be added later, just these days now, then my recommendation would be do the simplest thing first, and then have it live for at least one fork, see what the actual behavior on mainnet is like, and see if people are complaining, see what the delays actually are like once we clear out the historic withdraw queue, and then if it does seem to be a very significant problem, we can add it in a future hard fork. Would be my vote.
Does anyone oppose that? Cool. Okay, so I think we have consensus. We're going to keep working on polishing POTUS's PR. So that's 3068. And that sort of supersedes 3042, which was kind of heavily discussed before. And I suspect in the next 2 weeks or so, we should be able to have something that's quite final and potentially merge into the spec. Yeah, so we can keep making progress on the withdrawal front. Anything else on those two PRs?
Just one thing to chime in here, and I think there's been a lot of discussion across both of them, but the one thing with this approach is just making sure there's not like, undue extra load if there's reworks. So, rather than going at the epoch, we're now basically moving the processing into a per block setting, and that's fine. But, if there's like some crazy forking situation, does this like put more cache pressure or something like that that we don't expect? So
yeah, so the way I'm thinking of implementing this, I'm gonna do this today. I think it's zero optimization. It's just run the loop whenever we update head. And I think this is immediately reorg resistant because you're just gonna compute it again on a reorg, and there's essentially no load. Because we're doing this full loop anyways on Fortress. Once we realized that we're doing this full loop anyway in Fortress, then I didn't mind any of these implementations because all of them don't suffer much of a performance issue. That was my first concern, and that's why 3042 I think with Paul as well. But then it turned out that it's really not that bad to do that full loop.
when you say full loop, you mean a full loop over the entire validator set?
Yeah, so, and we're proposing to add this bound, but even if we didn't have this bound, it would be fine to just compute it on a reorg immediately again. There's no need to cache here anything. We would need to cache if we add something like Lion's proposal to have like the list of fully withdrawal indices per epoch. But if we don't need to cache anything, I think it's fine just recomputing it. You only compute up to 16 withdrawals per block, and that's it.
Right.
Also, the point to note is that the worst case scenario is when we do the full loop. Most of the times when most of the people would have set their payout address, I think we might just end up doing in 30 or 40 props at best. I mean, at worst. So it won't really be a full loop anyway.
So typically the loop is going to be only the next 16 validators, except the few that might be exited. But the problem happens if the full network has done already a loop. So everyone did a partial withdrawal, because with this proposal, with any proposal, all of your validators will be with 32 ETH and not much more. So if you spend like a week leaking, then all of the validators will be below 32 ETH. None of them will be withdrawable. And then in that situation, you're going to do this loop on every block.
And you're still saying, like, even in that situation, from your benchmarks, it's not an issue. So either way, I think
not really
we should.
Issue. If we put this bound at 100K,
right.
I think it's in the microseconds per loop.
Right. So yeah, I mean, I think we go with what Tim said. This is the direction, but also just everyone listening as you're implementing this, just think about this particular topic.
On that topic, one more question. I haven't really seen the proposal yet, but so excuse my ignorance, but the effective balance, how much does that change? Because that's actually, when the effective balance changes, that's actually a little bit more expensive, because then we have to hash tree route things, the validators in particular, and that's, as everybody knows, one of the bigger pain points performance-wise.
But so there are two kinds of withdrawals. One of them is already on exited validators. The balance is going to become zero. And the other one is removing all of the excess from the effective balance. So the effective balance is not going to change. It's going to continue being the max effective balance.
All right, great, thanks. I
think we also were discussing to leave a little bit of margin, so that we don't really drop the effective balance, even if, for example, there are a few missed registrations. So I'm not really sure whether people feel strongly about it,
but I think that's not really the reason, right? You cannot miss your effective balance by just missing attestations.
Yeah, the hysteresis takes care of that. You'd have to drop down to 31.75 balance before your effective balance dropped to 31. So you've got 0.25 ETH margin.
So if I understand, the comment is that whenever someone withdraws, after withdrawing, it will trigger a change from the process effective balance updates function. Is that intentional?
No, why would that happen?
So process effective balance updates, what it does is it enumerates state.validators, and if the balance has deviated sufficiently from effective balance, then that would be updated, and that's what's going to happen when you withdraw.
Why would that happen? Your validator never, so it changes your balance from all to zero, and that's going to happen on all full withdrawals anyways. And on partial withdrawals, it's not going to change your effective balance, because
I'm talking only about full.
Okay, but then on full withdrawals, these validators are already exited, so there's no problem that that the balance becomes zero.
Right, but that's going to incur extra hashing, but I guess that's fine.
Question to Botus. Are you suggesting to have this limitation on the maximum number of scanned validators in the spec? Like 100,000, as you mentioned.
Yeah, it's just a constant, right? So it's going to be some configuration constant, some preset.
Yeah, right. Yeah, it's not in the PR yet. Right?
It's not in the PR. I wanted to see if there was consensus. It seems that there is consensus, but someone raised now the issue of like the minimum scheme amount, and I'm not sure if Jim is here, but Jim has a good point. I think it's a valid point that if withdrawals are too cheap, then it becomes expensive to produce proofs for them, because the withdrawal itself doesn't pay gas, doesn't pay the gas of the proof. So that's the actual reason that Jim is proposing to have a minimum scheme amount. I am very skeptical in putting such a constant, because this depends on the price of ETH. So if we put a constant now, it might become a lot in a couple of years, and then we need to change it, and that requires a hard fork just to change a silly constant.
Yeah, again, I think from a simplicity perspective, I think we leave that bit out. And if you need to, you can batch your proofing right at the EL.
I just want to bring to attention that in consensus specs, there is a test case in which the validator is withdrawing, as well as it's present in the current sync committee. So in the consensus group, I have sort of mentioned the two tests, and maybe those can be rectified.
Okay. Anything else on the withdrawal PR? Micah, I don't know. you can't trigger. I guess if your balance is, you're going to be automatically partially withdrawn every block if your balance is above 32 ETH. So I don't know that.
Oh, I missed that.
Yeah.
I didn't realize this was fully automated. Okay.
Yeah. So we are DOSing the queue ourselves in a way, and okay with that.
Yeah, apparently.
Yes. Okay, sweet. The next thing is kind of related. Alex, you had, I don't know if it's your PR actually, but your PR about adding withdrawals as part of the engine API. Yeah, do you want to give some quick context on that?
Sure, yeah. Okay, yeah. So Tim just linked it in the chat. That's very helpful. So there shouldn't be anything here other than silence, because I think this has been reviewed. Basically, it's just adding the extensions to the engine API to support withdrawals. And yeah, okay, it looks like there's just a comment by like client, but otherwise, yeah, I will address that. And then basically, I just wanted to give everyone one more chance to say, we should change this or we should hold on it. Otherwise, I'll go ahead and merge it, and this piece will be settled. So does anyone have any additional feedback on this?
I have sort of used it, implemented it, and interrupt with get, and it works fine. So thumbs up from my side.
Nice. Okay, sweet. So yeah, we can go ahead and merge that. Next up, there was this issue about adding the block value in the engine API. We wanted to discuss this on Encore Devs, ran out of time. And the idea is that this would help validators compare the value of their local block to something they get from an external builder. There was a bunch of back and forth on the PR about how exactly we should compute this value and what's the right comparison to have. I don't know. I think, Terrence, you were the one to bring it up on Encore Devs. Do you want to give a quick update on where we're at with this?
Yeah, so I just want to say this PR will be really helpful as like the baseline for censorship like resistance for like just defense against censorship. For example, we can have a client flag. They basically implement a ratio and you can compare, say like, okay, if the bid from the builder is half less than my local block value, in the case, I will select my local block essentially. So I think this definitely opens a lot more avenue to this type of defense. So I really want to see this happen. In terms of progress, I honestly cannot say much. I have been following as well. It seems to me maybe Lucas from Nethermind or someone else comment on that.
So in terms of progress, I think it's fairly easy to implement in any client. The thing is just focusing on the spec. What do we want to implement? Because I've seen that in GEF it was, I think, prototyped as only the fees was returned, while, for example, in the old Flashbot spec, it was the delta between the balance of a fee recipient before block and after block, while the proposal here was about just the balance after block. So we just need to figure out which one we want to do, and that's it. So from my opinion, the balance after block is the easiest, but it depends on the use case. What do you want to compare, right?
So I think we want the diff, right? Not like the complete balance, because then you can just directly compare that to bids from remote builders.
Mikhail, your hand is up.
Just a quick comment on that. I feel like, I feel like we should have something simple here, and it definitely should be compliant with how the bid is computed by builder. If we will have any fancy logic of computing this bid, and then we will incorporate this logic into EL, and then this logic, after sometimes it's changed on the builder side for whatever reason, we'll have to change this on the EL side as well. And this is what just, what I would try to prevent from happening, designing this particular thing. So we just need, I think that balance, absolute balance is fine. The diff is also fine, but yeah, something else probably be more just adding more complexity without any gain.
So I would
like
to add provide some opinion on this. I think it should be diff because that is the perfect target that builder may converge to, and most of the times builder will also match the diff. For example, if there is no self-initiated withdrawals or there is no payment into the builder account, so most of the times it will match, and for the engine API, it should always be the perfect fees that is being paid to the fee recipient. So maybe over the time, builder can find a way to converge to this, but 99% of the time it will anyway match.
Chris, you want to give the perspective from the Flashbot side here?
Yeah, there has been lively discussion about the block scoring and whether to score it as the diff or as the value to payment transaction, which seems to more accurately reflect the additional value provided to the proposer, because otherwise transactions to and from the proposer fee recipient will inflate or deflate this value without any doing from the block builders. I guess any way to implement it in GEF or in the engine API, it's fine. But there's another discussion going on about, in the builder specs, what should be the bid value? Should this also include mempool transactions to the proposer fee recipient? And there is some back and forth on this. I post the link again here. And it's also a question about what is the easiest to, if we would include a payment proof as part of the bids in the builder specs, which type of proof would be easy to validate inside MEV-Boost? So MEV-Boost could filter out bids that are not conforming or that the proofs are not valid, if that makes sense. So I think in general, there's no clear consensus which way to go, but it's an important discussion that we would like to see moving forward.
Got it. Anyone else have comments or thoughts on this?
So my comment here is that I'm not sure if we are talking on the same level, because we are. I think this discussion is about consensus client and its configuration, being able to pick local build block, even if it's slightly worse, for example, but it needs to be able to compare how worse is it than the one from the MEV-Boost, and just pick up because someone is fine not receiving small amount of additional fees in terms of providing uncensored blocks, right? That's I think is the final value. And you're talking about payment transactions, things like that. We don't have this concept here at this level.
Well, but it compares to the bid value that the builder network provides as part of the bid. So there is like this semi-relation here, because you're going to compare it to this block score that is not yet divided. So I agree, it's not the core question, but it's related, and just wanted to bring up the connection.
So one property that I kind of like about doing the diff is that it kind of improves, like it encourages transactions, or like transactions to the builder or to the validator in that case, increase the likelihood of the block. So if I have a transaction that pays 20 ETH to me, then this will increase the diff, and I will be more likely to put this transaction into my block. The problem is the other way around, because gas will always include local transactions first. All of my transactions that decrease my the amount of money I have will negatively impact my score, kind of unfairly, because it's transactions, and it's not really that I'm losing money because of this, because of the block that I sent.
Right, and if MEV-Boost decides to use block scoring, then it would be using the same strategy as the EL, and therefore they'd be directly comparable. If MEV-Boost decides to go with, or the relays or whatever, whoever's doing the block scoring, if they decide to instead go with payment transaction, then the situation you described comes into play. So, Mikhail, I think the problem here, if I understand correctly, is that if the relays are submitting bids in the form of payment transaction and the EL is submitting bids, or the equivalent of a bid, in the form of fee recipient balance change, then the two aren't actually comparable because of the reasons that Marius just mentioned. And so either we need to accept we're comparing two things that shouldn't be compared, they're basically different units, and we just kind of accept that, and in some cases we're going to get it wrong, or we do the same thing as the relays are doing in terms of what their bid submission is. Or the relays submit a bid and they also submit the thing BL is doing. So there's basically two versions of the bid.
My understanding is that we just try to evaluate the value of a block, of a local block, and compare it to the value of the externally produced block.
Well, and that's so we don't know the value. We don't know the value of the block coming from the relay. We only know the bid that was supplied.
We know the claim. We know the claim, right?
Right, but the claim is a different unit. The claim is, what is the payment? Let me rephrase that slightly. The claim being made is either going to be, we claim the balance of the fee recipient increased by this much, or the claim might be, we claim that the fee recipient received a last transaction in the block that paid them this much. And those are two different things. And the relays and MEV-Boost and all that haven't decided which one they're going to go with yet. And so if they go with the latter one, then the claim they're making is not comparable to the balance change of the fee recipient in the block.
Yeah, I agree with that, but I don't think it should be comparable. I mean, like the algorithms, like the ways of evaluating these two bids, let's call it this way anyway, is different. But yeah, I think that it's okay. I mean, it's if builder claims that it pays proposer this amount of ETH, and locally build block is estimated with a higher amount of ETH paid to proposer, then yeah, that's it. We just need to set the right algorithm for estimating the local value that we can get for proposer.
Right, so the problem is, as Marius indicated, there will be situations where the locally built block will underestimate because the user is sending a transaction from the fee recipient address. And so therefore their balance decreased over the course of the block.
Ah, yeah, I see what I mean. Yeah. That's
fine as long as the bid, that's fine as long as the bid from MEV-Boost is of the same form because they're comparable. And so if both of them include that balance transfer, then there is an edge case because gas will include local transactions, whereas the builder won't. But you know, for the normal cases, I don't think that's an issue.
Yeah, just to boost what Chris said in the chat, this conversation has been had in other places. And yeah, this is like a known sort of con to this plan, but the general, I think, like solution here is just say, yeah, like validators, like how often would you have a validator sort of have a transaction that would decrease their balance when they're also proposing a block? And I think it's pretty rare.
This is only a problem
Well,
if we're trying to figure out the balance or the amount receives if you're building locally.
Well, in any case, I mean, I could gossip the transaction that like sends
But-
20 for me.
but if
Yeah, but if I'm building
other people-
locally,
So
sorry, go ahead,
if-
Marius.
I think that it's actually a really important use case. If I'm being censored and I have a validator, I can build locally and get my transaction in.
So how would you know that? Because then you could just say ignore MEV-Boost entirely and just use the local pathways and like force it through.
Is there a case maybe with like staking pools or whatnot? Like mining pools would prioritize their transactions and payouts and whatnot at the top of the block. So could you imagine something like there's a large validator who, like when they propose a block, they like to include their transaction first or whatever. And so, well, it's a balanced diff if it comes, oh, right. It's a balanced diff if it comes from
Yeah.
that same account. But they could, I guess if this was they could just use another account or something and sidestep that.
Actually, if we rethink on the balance diff, so the balance diff for me is like you have this balance before the blocker has been executed on the recipient address, and you just has another one after the blocker has been executed, and you do just the subtraction and calculating the diff. The other way is to pay with all the fees, right, that has been charged to the recipient address. And I think that if we will not account if we use the former approach, we will not account for coin-based payments and direct transfers to the peer recipient address, which is probably fine because this type of payments are usually used by searchers, right, and probably builders to pay to the peer recipient, not something that you can grab from your local mempool. Which means that probably the sum of fees received is a better approach.
Yeah, I'm not sure what this debate for the balance diff at the local EL layer is about. Like,
So
it's already trusted, so we don't need to have any kind of proof against things. Like for me, the reason to do the diff is that you can prove it against the state easily.
It's so you can compare against the MEV-Boost block, so you can decide whether you should include your locally built block or the MEV-Boost one. One can imagine MEV-Boost.
But you can do this with
block.
sum of fees.
What do you mean?
I'm saying you can calculate the total sum of like the tips of the transactions, regardless of how many transactions you sent from your account. And then that's the value of the block to you.
So what about
because you're assuming that, look,
I didn't catch that.
Go ahead, whoever else was talking.
I was just asking, does sum of fees include coin-based payments?
Presumably no, but there wouldn't be coin-based payments in your own block that you build locally, most likely.
Wait, why not?
Because your local EL isn't doing MEV extraction, and so there's, I mean, someone could send you a coin-based payment, but no one does. It's one of those things like, why would someone just be giving the block builder free money?
Because you're extracting long tail MEV, and so this is like.
Then you're running a different builder, like I'm talking about, like the stock client mechanism. And there's nothing precluding clients from adding support for tracing all of the transactions of the block and adding this to the total sum if they see a coin-based payment. There's just no reason to like subtract from that value like something sent from the Coinbase.
Yes, I see your argument. It's not unreasonable, and it gives a high estimate. So if we say, if we're assuming stock EL that doesn't do any sort of MEV extraction, just does, fair ordering for some value of fair, then the fees that it gets from transactions is basically all it's going to get in the standard case. And that will, I think, generally be an optimistic estimate, and potentially higher than MEV-Boost, especially if MEV-Boost is doing block before and after diff. And so that gives it a little bit of nudge towards using the EL build block, which is nice.
I don't get why you're comparing these as if they're like different mechanisms. They're both outputting like the value of a block to the validator.
Oh, so again, the goal here is to compare, like my EL built a block and MEV-Boost is giving me a bid that means something. If those two things are counting different numbers, like if MEV-Boost is saying the balance after versus the balance before, and in that block there was a transfer away from my account, then MEV-Boost will score the block low. So it's going to say, hey, you made 1 ETH, whereas my local EL is going to say, oh, you made 1.2 ETH because I didn't subtract that out. I only summed the fees. And so the local EL will have a slight advantage there. And therefore, you will choose local EL block instead of the MEV-Boost block, even though the MEV-Boost block may have actually given you more money.
I mean, sure, but I think that if we were to use a state diff, then we have to have an invariant for people using MEV-Boost if they can't be sending transactions from their fee recipient during that block.
Yeah, I think your way is reasonable for the EL side, since we don't need to prove anything.
So, like, beyond discussing just these approaches, like, what's the best way to, like, prototype it and get this actually tested? Where should, like, the conversation happen, and how do we get, like, a prototype of it? So,
so we have a prototype.
We all agree that we should go ahead.
And Prism already has a prototype, I think.
Okay, so Geth and Prism have a prototype. Doing what, actually?
I'm computing the fees, just the normal Coinbase fees, and returning them to Prism, and Prism is...
Yeah, I am getting the fee from Mario's branch and comparing it and just pick the highest one to go. Sorry, and if the local one is higher, we just skip MEV-Boost.
Got it.
I think we need to like push the conversation forward on the engine API PR.
Yeah. Okay, and to be clear, there's no PR yet. Right now, all there is an issue like this RFC. Oh no, sorry, Marek
there's
has
add
a PR.
engine.
Yeah.
Oh
no.
This is all boxes. Versioning get payload to support locally built block value.
Okay. I can't find it right now, but
I can post a link.
Cool. Okay, so yeah, let's move the conversation there. Okay, awesome. Thank you. And yeah, I don't know beyond that.
Yeah, I mean, what kind of timeline are people interested in for making something like this happen?
As soon as possible.
Double ASAP, triple ASAP.
Okay. I mean, yeah, so it would be great by next meeting to merge the PR.
Yep.
So if people could review it. Yeah, in the next meeting, we can talk about cutting a new release for the engine API and figuring out how to roll it out.
Cool.
We still don't have versioning solved for engine API yet, right?
No, we do.
We have solved it. Just need to spec it out, and yeah, we can have a PR, so it will be if the new methods and structures following currently specifies versioning that we currently have a small piece of versioning spec in the engine API, so they will be forward compatible with the whole design. It's very simple. I mean, the design of like introducing new methods and how this will be handled by clients. And yeah, with respect to this peer recipient payments, we agreed on submitting a PR and taken the conversation of what the computation of this value will be to some other place, right? Or we agreed on that it will be some of your recipient payments in the block, like not payments, just transaction tips.
I think we just settled on tips. I want to make sure that this is not gameable, but yeah, that's the simplest thing it sounds like for now.
Wait, so I thought it was more that in the execution API, like you're getting a value with your execution payload or whatever, and since this is coming from a trusted node, we don't really care about like how it's derived. It's like you can, someone implementing the execution API can do it however they want, but it's trusted, so it doesn't matter. We don't have to prove it.
Definitely.
There's still value in all agreeing to do the same thing.
I think the important part of the most important part of the agreement is that the CLs all assert that we will compare the number the EL sends us against the number we get from MEV-Boost. And then if someone wants to run an EL that, you know, fudges their numbers up or down or whatever, that's on them, like they can. Or if someone wants to build an EL that fudges numbers up or down, that's fine. I think as long as we have standardization on what comparison is being made.
Are the CLs wanting to also do some kind of wiggle room? Because it's probable that MEV-Boost block will be better, but if, for example, it's like 5% better or 10% better or whatever maybe the user could set, it still would go to the local one, for example. So if someone is okay with losing like 5% of the rewards to just supply censorship resistant, for example, but if he gets like 200% tip in this block, maybe he still wants to take MEV, right?
Yeah, I think that makes a lot of sense. I also think that's like a different conversation, different PR. So this is like the foundation, and then from there we can say, okay, separately, someone is going to have to make that comparison, and then you can also, like you're saying, add in that, you know, this wiggle room.
Also, there is a corresponding PR on the builder specs. I mean, if anyone wants to chime in there as well.
Can someone post the PR to the builder specs in the chat? Get a second. Okay, we have a couple more things to cover. Anything else on this? Okay. Thanks everyone, and yeah, we can follow up on the next call and see where implementations are at. Okay, the next big PR is this rebase of 4844 on Capella. Basically, there's work happening on 4844, and I think we have pretty strong consensus that like withdrawals are the first thing that's going to be prioritized on the CL side. We'd like to get 4844 implementations done so that we can potentially ship them, if not together, very close to one another. And the sort of way we've discussed doing that is having 4844 rebase on top of Capella, so that you could imagine activating them one epoch apart or something on the consensus layer. And yeah, I know there was a lot of discussion on this PR and how we want to approach it, but yeah, and Xiaowei had some updates on basically making a lot of the withdrawal stuff no ops. I don't know if this still applies given the change in withdrawal spec. So yeah, curious what people think we should be doing with this one.
I was pretty happy that we were able to come into some sort of decision on not having the queue in the beacon state. So I think like it's fairly easy to move forward now. So now we know there's not going to be a queue in the beacon state, but within the block, you still have those like BOS to each one signature changes, the address changes, and those can be stubbed out with like empty or zeros. So yeah, I don't see anything that's blocking this PR right now. So yeah, I'm happy to approve it, or anyone else wanna approve it as well.
So from Lighthouse, like we were pushing for this, but since other teams didn't really like the building on top of the unstable changes in withdrawals, we're working like on our side to make withdrawals completely disableable. So our position is now just like whatever can support other teams more easily. And I guess generally it sounded like actually merging this into the consensus spec repo might not be great in terms of like just the general structure of the repo and like testing infrastructure. So it's another point.
Yeah, also the beacon state structure is going to change. So I'd suggest to hold on that PR a couple of days, at least until we get the PR with the actual beacon, new beacon state and all the structures that you will need on the consensus side.
Okay. And then in terms of implementing and continuing the work on 4844, people can just stub out the withdrawals as they were previously doing, or what would be the best path there?
I don't have a strong preference on this. I mean, I think for us, we can follow other clients if other clients have strong opinion on this.
Yeah, I think for us also, like whatever would better support clients that might be further behind in development. So
any other client team have an opinion here?
So perhaps I missed the question, but I think so. If I understand correctly, there are two things to test. One is 4844 and the other one is withdrawals. And it seems that withdrawals, the execution layer is already ready to test. At least that's what I'm getting from Marius. So my guess is that we can try to give them clients now with the actual structures for withdrawals so that we can start testing right now the execution side.
Yes, please.
Yes,
as soon as possible.
Less than a week.
So yes,
in just a couple of days.
Yes, so that's definitely something, and I think that the other challenge on the 4844 side is I believe the Prism implementation was built with like 4844 after the merge, so like after Bellatrix rather than Capella, and others are starting to implement it and would rather have 4844 after Capella. And so making them interop together is a challenge just because of that. I think if we
my suggestion there is that we actually ship today or tomorrow or as soon as possible the actual structures on our clients, just the structures, because then they can be stubbed out. I'm gonna have this on Prism today.
Yeah, so basically we can do with Capella or without Capella. I mean, yeah, basically we have two options, and I think we can go with whatever other teams prefer.
Yeah, I think if it helps us with the testing for withdrawals to just get all the structures implemented in clients and move that forward, and then we can stub them out when we're doing the 4844 stuff, that seems like the best approach. Does anyone disagree with that? Yeah, and obviously, we need to get at a high level all the withdrawal stuff done before. So let's have teams focus on that, and then the 4844 people can just work with those structs and stub them out. Cool. Anything else on this PR? Okay. Jacek, I believe you're the one who proposed the historical batches PR. Do you want to give a quick overview of that? Here's a link.
Yeah, sure. So this is really just a small cleanup of one of the fields in the state. Right now, for those that haven't seen that PR, it's basically that in the state we have this historical roots field. It's basically a Merkle root of all the blocks and all the state roots of all the history that led up to that particular state. What the PR does is that it splits it up into two lists, historical roots, or rather that you can get the root for the block root separately from that of the state. And what that enables is that whenever you have 8,000 blocks, like the data of them, you can verify that these 8,000 blocks belong to that state without having to recompute the state root. Which is nice for archival purposes, like you just grab a checkpoint state and you can immediately verify all block data against roots that are present in that state. The PR itself, it's gone through a couple of iterations. It's kind of simple right now. I think it's like 10 lines or something. In the beginning, we thought we'd like kind of backfill some of the information, but we've come to the conclusion that the information that is to be backfilled, it can be shipped as a constant because it can be verified against other state data. The other simplification that PR has gone through is that the new field that it adds now ends up at the end of the state, so that we don't change the header of the beacon state, so that if you're reading like the first n fields of the beacon state across different forks, that'll continue to work. The PR itself, the idea came kind of late in the Bellatrix cycle, so we decided to postpone it. I think now would be a good time to just throw it in. Happy to take questions.
Yeah, do any other client team have comments or thoughts about this? Okay. I guess people can comment on the PR directly if there's anything. Yeah, and once there's a bit more feedback, we can probably make a decision on it. Thanks. I guess next up, there's been a lot of discussion recently around Goerli's supply issue. So it's really hard to get Goerli Ether, and people are literally paying for it, which is not great. There was a community call earlier this week, which Afri ran to go over these. So Afri, do you want to maybe take a minute to talk about the different kind of things that came up there, and what are the proposals that like we can maybe do on the CL side to help with this?
Yeah, sure. Thank you. I mean, testnets, Goerli specifically has been an issue for a while now, specifically with the total supply just not satisfying the needs both for stakers that want to test staking setups, but also application developers. And with the amount of testnets we deprecated this year earlier prior to the merge, there are a lot of applications and layer 2s migrating to Goerli, which does not make it easier with the supply issue currently. So we had a community call 2 days ago and we discussed various things. And there's always two sides to this discussion. The one side is the client teams that really don't want to put so much effort in testing infrastructure or testnet specifically. And on the other hand, there are application teams that ideally just want to have one functioning testnet for literally forever. And our challenge now is to find a middle ground here. And one thing, because so the easiest way for us would be to just deprecate Goerli and start something new. But the issue is that so many teams are currently migrating to Goerli, and we kind of missed the chance to communicate this properly, what the state of Goerli is and what the future for testnet looks like. So one middle ground would be to find an intermediate solution to inflate the supply. And there was this discussion if the withdrawals with Capella offer us the opportunity to maybe have something in the consensus layer specifications that would allow us to tweak some kind of factor that would allow us to inflate the Goerli supply. And I submit the pull request to the ETH specification, the ETH consensus layer specification that proposes a withdrawal boost factor that would be is basically a multiplier for the withdrawal amount that is always 1 on all testnets, but it could be tweaked for testing or testnet purposes. And the discussion is now, how trivial would it be to implement this? I mean, it would be trivial, but what are the implications? What are the downsides? Is inflating the supply generally a good idea? If anyone can do it, and yeah, if anyone has any comment on that, I would appreciate it.
And maybe one extra piece of context of like why this is a CL thing is on the EL side, there's not really the ability to change network parameters after the genesis is set. Whereas the CLs use a bunch of constants that yeah, the CLs use a bunch of constants that can be like extended, and so this is just a easy. It seems like a low impact from a code perspective way to add a constant that's set to 1 for mainnet, and then to something else for other networks, so that when people withdraw, that's a way to increase the Goerli supply. And the biggest risk is obviously that you can then have like a sort of infinite loop of growing the supply. So, you know, you can launch a validator, withdraw, multiply your Goerli ETH, and then do that over and over and over. So there's a point at which you would exceed like what clients can handle. And I believe Lodestar has a relatively low value, which is something like 70 million times the current supply. So like there's still some room to grow, but yeah, people can just withdraw, increase their ETH over and over. So that's the risk. Yeah. That said, if we could get this changed, then it would help with all the supply issues on Goerli, which is great. And if we can set the constant to something that's relatively low, that we don't expect to be hit too quickly, I think it's probably quite valuable. And also, I think Perry, someone who mentioned this, we've had proof of work testnets in the past. Proof of work testnets have a lot of like fatal flaws in their design, and people have generally not broken them. So there's a hope that like users will be somewhat altruistic here and won't destroy Goerli with this attack. And I believe most of the Goerli validators are controlled by client teams, the EF anyway. So like, yeah, a large part of the stake would probably not be malicious.
Doesn't it only take one person to execute this attack?
Yeah. So somebody can like slowly, you know, start from 32 ETH, double it, and then eventually become the core of the validator set. Which could give us.
So having a mostly altruistic validator set doesn't really help us at all. Like
well, it
one
helps.
Person can just.
It helps slow down the rate at which this attack would happen, right?
I feel like before we even like debate the actual mechanism, we should determine if CL teams are even willing to accept a testnet specific parameter or fork change.
Right. So they accept the testnet specific deposit contract, but yes.
So for Lighthouse, I'm not fully opposed to doing something weird to help Goerli out. One concern that I have is that we really pay in terms of client's performance for every validator index that's created. And if we create a scenario where one person or a few people are incentivized just to spawn validators and then exit them to make a lot of Goerli, which I think people will just do, then we're going to blow out the size of the validator registry and we're going to make it really hard to process the chain. That'd be my concern with this approach.
Got it.
Well, growing it to the double of the current validators at Goerli wouldn't be bad actually, because once we enable withdrawals, we need to be ready for that, right?
I mean, it would be an interesting test, but if we want to have Goerli as a place where people can test things, it might, like, if they want to be able to have a stable operating environment, it might not be a good idea. It'd certainly be interesting for us, but I'm not sure if it'd be great for the intention of it.
Okay, so I guess then the next question is it the right decision to try and improve the distribution of Goerli ETH? Because we do have this testnet Sepolia that we kind of are wanting developers to move to, and that should be like the preferred place. And if we resolve this supply issue for Goerli, I think that Sepolia, there's not as much point for it because the developers aren't going to move.
I mean, I think there are two core issues here actually. One is that, well, there's a dual use case of Goerli. One is to test out your validators. And that requires 32 ETH, which is a whole lot, right? And then there's applications that just want to, you know, I don't know, Uniswap, whatever. And they don't require as much ETH, or somebody wanting to test their Uniswap transactions or whatever. Could something be done to keep the two apart?
Yeah, I think that there is work on creating a like staker testing specific testnet, because it doesn't make as much sense to have those two things together. So that the staker aspect is being resolved. So I think we're like really thinking about these people who are like trying to test on a testnet, to like run integration tests across many applications. And so the question is like, do we want to resolve this for Goerli? Like, what is the future of Goerli? And to me, I was thinking like the right thing was to kind of let Goerli die over a longer period of time and then push the developers to Sepolia.
There's also a way of keeping Goerli working for stakers and having the full testing environment if you just have a contract that is founded. And I think each staker is already deploying these things, where you just send very little Goerli and then the contract deposits for you. So you send a deposit that it's exactly the same experience. It's just that you send a less amount, and then the contract acts as a proxy and deposits for you. So it keeps Goerli working for people that want to stake. And I agree with Lighthouse, with Light Client, that if we fix Goerli, then we're not going to see developers moving to Sepolia.
I want to make two comments before we move on with this discussion. This withdrawal boost factor is just one of a couple of measurements we want to take. There is also Mario working on the stakers testnet, so we are trying to have a different solution for people who specifically want to test staking setups. So this is like an entirely different discussion, and we don't need necessarily have this right now. And also, I have been working on something I call a testnet release schedule that is kind of predictable. So which testnet should be the primary testnet is also a different discussion. For now, I would like to focus on feedback on how to fix Goerli, or if we should fix Goerli at all, or move on to another testnet. That would be really appreciated if we can discuss if something like a withdrawal factor on the consensus clients would be feasible.
So does anyone feel super strongly to keeping Goerli alive for the longer term for developers? Or is everybody on board with trying to make Sepolia the default place for application developers?
So it depends what you mean by like long term, right? Like I think it's unrealistic to think about shutting Goerli down in say the next 6 months. Like I think we've shut Ropsten and Rinkeby down, and some people are like in the middle of like migrating to Goerli. I don't think there's as much infrastructure support for Sepolia yet as there is for Goerli. So like, sure, we can push people off of it. I think that is still like a, call it 6 or so months, probably more like 6 to 12 process. And it's like, what do we do in the meantime? And it might be fine to just say like, look, even if it takes a year and it becomes weird for a year, that's okay. And we move people to Sepolia. And we can invest our time and efforts in building something like a staker specific testnet, which shuts down gradually or frequently. But yeah, I don't think we can like say we're gonna just turn off Goerli in 3 months or something.
There was another idea that kind of came up in chat now. We could, in the next fork of Goerli, change the effective balance and the ejection balance as well, so that when partial withdrawals and withdrawals are enabled, we kind of free up locked Goerli ETH in the deposit contract. It wouldn't solve the problem, but it would at least free up existing locked Goerli ETH. And a lot of the freed up amount would still be under the control of client team /EF, so we can solve the allocation problem in a separate manner, probably with hopefully better faucets or whatever the solution there is.
Sorry guys, but what if we'll have this schedule of network disabling? What would happen to users that want to check what can happen to their stuff like NFTs and stuff like that after, for example, the period that archive nodes keep their data? So how can users be able to test long-term effects of their contracts and their stuff if we will have like schedule of killing networks every, say, half of a year?
What's an example of a long-term thing you think that like
how data can survive after it is migrated from, like, I had something made recently, then I waited for a period of time that is longer than our like period of fresh node, the period when data is like kept in archive node. How can I check that the data is still alive, still accessible from the nodes that are currently in the network? So such kinds of tests.
Is that something the network should guarantee?
It's something that you want to test, and I think it's actually valid. Okay. There should be some longer running testnet.
Well, the longer running testnet could still be supported, right?
Yes, exactly. The way I see it, this like ephemeral testnet is more for testing, for giving stakers a way to test. Yeah.
And why
just test their flow?
Why do we think Sepolia won't end up in the same state as Goerli, fast forward 2 years from now?
Like we have the ability to mint as much ETH as we need.
Oh, because of the
token gated withdrawal contract.
Okay.
Yeah, we kind of deployed a couple of tricks when deploying the Sepolia beacon chain. We have Genesis validators with a couple million ETH Genesis balances, and we can withdraw them or partial withdraw them or whatever. And we have the token gated deposit contract with another couple trillion ETH.
Okay, and we can mint ETH in that token, because we also had like the Genesis whales for Goerli, and clearly that's not sufficient long term. But like if we have the ability to mint additional ETH through the token contract, I think that's probably like the big differentiator. Yeah. Paul, for your suggestion, we had proposed that the EL devs and they were against it. So if CL devs want to do that, that works. I guess it's worth.
That would actually be the most straightforward way.
So but even if we do want to move to Sepolia, like in the medium term, is it worth speccing out this effective balance change? Because that seems like something where we're not actually adding a new constant to the spec. Like with the withdrawal boost factor, we don't run into this potential like infinite loop of supply issue. And like given that most of the Goerli ETH on the validator side is most of the Prater validators were run by client teams in the EF. If we have a lower effective balance and it allows all those teams to get a ton of Goerli ETH, I think it's reasonable to like have them distributed to faucets and whatnot, and it might just buy us some time. So is anyone strongly opposed to that, or is it worth at least putting together a spec for it and seeing what it would look like?
I think I'm generally opposed to modifying Goerli.
Just because we want to move people to Sepolia, is that the main reason?
Yeah, I think if we modify Goerli, then it makes it pretty unlikely that we'll ever move to Sepolia.
Okay. Anyone else strongly opposed to this? Or
I'd be tempted to say if we were going to bother with doing a fork to change the max effective balance, then I'd be tempted just to do like a regular state balance transition and just dump $1 trillion ETH into Parry's account. It seems like it'd be easier to me. I mean, into a validator account.
Yeah, I guess I just see like the mechanism which happens is like a separate discussion. There are many ways of doing it in a good way. To me, we agreed that CL devs are okay with doing some sort of irregular type of fork for a testnet. Then now the question that we need to really answer is like, are we going to do something about Goerli, or are we going to push people to Sepolia?
Yeah.
And then once we agree on that, then we can like decide like how to make it happen.
Yeah, that seems reasonable. Do we have a testnet channel or something in the R&D Discord? I don't think we do. I don't know where's the best place to have this conversation.
We have a testing channel.
Yeah, they're used for actual
There's
tests.
a testnets channel under the CL category.
Oh, is there? Okay. Okay, so let's use that to continue this. I literally had that channel muted for some reason. Let's use that to continue this conversation. Yeah. And okay, we're already sort of at time. I know, Chris, you wanted to give a quick MEV-Boost update. Do you want to take a minute or two to do that? And I know you shared a link in the chat as well.
Yeah, sure. Just running through it. There is an upcoming release of MEV-Boost 1.4.0, which is a bunch of minor improvements, but a notable improvement is the ability to set a minimum bid value. So any proposer can define whatever value they want as a minimum bid value, and below that, no bid will be sent to the CL client. That's they're only notable. There is a bunch of minor improvements like logging and mutable relay flags, and you can see the details in the GitHub issue. Some related API updates, as we discussed before, the profit switching in the beacon node and the block scoring standards and payment proofs that are somewhat related. Ongoing research about inclusion lists inside and or outside MEV-Boost. Improving performance with SSC encoded payloads. There is conversations in both the builder specs and the beacon APIs. Previously, there was also the discussion about SSC subscription to trigger block production. That's stagnant at the moment. And a few stats about the relays. There are 8 relays currently producing blocks. We've put a table in there with the number of payloads in the last 24 hours by each one. And I put together a table of notable builders that submit blocks to the Flashbots relay that are landing on chain. So you can get a bit of a feeling of what's going on in the builder ecosystem at the moment. Yeah, that was the very short version. Any questions?
Okay. Yeah, thanks, Chris. Anything else as we wrap up? Okay. Thank you very
Call out, one more thing, just to call out the document I put in the chat about withdrawals progress. It'd be very good if we could get to a testnet by the end of the year. And I'm generally trying to keep track of everything. Let's see, I'm trying to find it, but here we go. Oh, I can't copy it. That's annoying. There we go. This one. What I just pasted in the chat, just everyone take a look.
Cool. Thanks, everyone. And yeah, next one of these, Danny should be back to run. Thanks for bearing with me today. And see you all on All Core Devs next week.
Bye-bye, everyone.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye.